just before class, I was looking at our whiteboard notes, and realized, I didn't post our meeting notes from last week. What the heck, right? So I thought what I would do is, and then I was looking for them, and I didn't see them offhand. I was looking at another class's notes. So what I want to do is just as a very brief review to pull up a set of whiteboard notes and just ask if those look familiar to you. And then one of the things that we want to talk about today, Connor, involves this concept of existential import. One of the things that I also want to get from you is feedback on how, for example, how the reading is going. If it's because it's text that I can change. I wrote it, right? But it's not like they're my ideas. They are part and parcel. They are just standard ideas and a standard development that you'd see in kind of any logic textbook. But if what I'm presenting isn't clear to you, then I want to get a sense of what your experience is, so that I can, if not adjust, I can't adjust the textbook on the fly. I just don't have time for that. But what I can do is then say, okay, I need to make sure that I'm paying attention to X, Y, and Z during our weekly meetings, or post additional notes or whatever to help you. Okay. That said, Connor, for what it's worth, existential import typically throws all of us off, at least initially. Okay. All right. So hi to everybody who's come in. What I'm doing is just launching right in, because I know that since we only have one 50-minute weekly meeting, we don't have a load of time. So I'm about to, share my screen. All right. So particularly, I'm sharing my photos with you because I want to make sure that you. Where did it go? Here we go. Okay, so does this look familiar to you? Because remember, for some reason, I didn't post last Friday's notes. And what we did was, as a way into the chapter 3 material, I said, okay, we know what validity is. We know what invalidity is. We also know what soundness and unsoundness are, but our focus in chapter 3 is going to be in terms of arguments, in terms of inferences that we make from one or more statements to another, validity and invalidity. So the overview is the two systems of deduction that we study, specifically initially anyway, the interpretation of a statement that's true or false from the standpoint of either categorical logic, which is what we're studying first, and then the propositional logic that gets us to the system of natural deduction. So first question to you, and do me a huge favor because I've got, the way I'm sharing my screens, I can't see all of your tiles. Do me a favor and either via the chat or verbally tell me, does this look familiar to you? Does it sound familiar to you? Anybody? Sorry, Connor, go ahead.
We only see a white screen.
You what?
We only see a white screen.
Oh man, all of that. And I thought I was sharing my photos with you. Darn it. I apologize. Okay, hold on. I'm not going to waste time trying to figure this out. So, well, then let me ask you this question. Does what I just said about, and I'm going to jump into our meeting with my other device so that I can share the whiteboard. Okay, does what I just said make sense, right? That we've started with a big picture set of concepts, right? Arguments that are valid or invalid, valid or invalid, sound or unsound, valid or crap. Sorry, this is what happens when I try to go fast. Start again, Mia. Arguments, right? What an argument is, all that good stuff. Arguments that are valid or invalid and sound or unsound. Arguments that are strong or weak, cogent or uncogent, right? That's our big picture. That's chapters 1 and 2. And we talked about some other stuff, but those are our big picture items. Chapter 3, we begin by talking about categorical logic. In other words, chapter 3 is devoted to two systems of what's known as deduction, or two deductive systems. The first of which is categorical logic, the second of which is natural deduction. Categorical logic is constituted by categorical propositions. That's one way to interpret a sentence that's true or false. Natural deduction is constituted by sentential, let me rephrase that, is constituted by propositional logic statements, which is to say statements that are true or false but are interpreted in a different way, a slightly different way, right? So they're often known as singular statements. Does that ring bells in terms of what we talked about last week? Anybody? Anybody? I hope so. Connor, not particularly. Okay. So let me do this really quickly. And of course, now I realize I also have. So Connor's saying not particularly. My suspicion is when we were chatting about this, because you guys were thinking about writing your first exam, which generally went quite well, and we can talk more about that. If you haven't taken it, don't wait too long. You don't want stuff to pile up, right? But does this ring bells to anybody? I know, Connor, thank you for sharing. I want to hear from you. Anybody else? Brian? Okay. All right. So let's do this. Bear with me. Or actually, let me do this instead. I think it might be, instead of my verbal, a quick set of whiteboard notes will be helpful. Okay, so overview of chapters 1 to 2, what we've done so far. We know what an argument is. We know that we can evaluate, so evaluation. We can evaluate an argument as valid or invalid. We know that a valid argument is either sound or unsound, and every invalid argument is unsound. Another set of evaluation concepts, and I'm not going to write the word on this left bar. Well, I guess I can go this. No, I'm trying to do this in a way that's legible. It's not going to work. I'm a lefty, so I got to do it this way. Sorry. Right, so we've got strong or weak. And then a strong argument is either cogent or uncogent. And all weak arguments are uncogent. Right? We also know, just as a reminder, an argument consists of let me erase that. An argument consists of statements arranged in a certain way, and we've got premises and a conclusion, right? So all of this rings bells, right? This is what you've been working on. Now, what we're going to do in moving forward is this. We're going to focus on two systems of Deduction, and that's chapter 3. And then we'll look at least two patterns of induction and experiential arguments that fail. I'll just do that. Experiential arguments that fail. And there are patterns there too. And that's chapters 4 and 5, respectively. Okay? So where you and I are now, what we started last week, was with the first of the two systems of deduction. So when we think about the two systems of deduction, we've got categorical logic, and we have what's called natural deduction. And, each of these has a way of interpreting sentences, interprets the logical structure of a sentence differently. Oh, now I've run out of whiteboard space. Darn it. Sorry. Differently. So, does this ring some bells? How are we doing? What do we think? Don't be shy. I want to hear from you. Is this a, yay, Mia, it's coming back now? Or is this a, no? Thank you, Jake. Okay, seems more familiar. Good, good, good. Remember, the work that we do in this class or any class like this is we say, okay, what's an argument? How do we identify the parts of an argument? How do we identify that we have an argument versus a non-argument, right? So maybe in the order of what seems, natural, you might say, okay, identify what an argument is, be able to distinguish an argument from non-arguments. When you're dealing with an argument, what are we talking about in terms of its parts, right? And we know that the singular characteristic of a collection of statements that we call an argument is inferential flow, right? You draw an inference from one or more statements to another. The connection between this collection of statements that are the premises and the statement that is the conclusion, that bridge, that inference connection, the inferential connection, I should say, that's what we evaluate, right? How well do the premises support the conclusion, or how well does what job does the argument do in showing us that the conclusion follows from or is inferred from the premises? Well, we can say, go back to our two sets of evaluation concepts, the structure of the argument is correct, which is to say the argument is valid. So we get certainty regardless of whether or not the premises are true. Or the preponderance of evidence is so overwhelming that even if I'm not sure that the premises are true, assuming the premises are true, the conclusion is very likely to be true, right? So we've got validity and strength. Right now, we're narrowing our focus to the systems of deduction where the evaluation of the inference is exclusively about validity and invalidity. Okay? So, quick recap. On the types of interpretation we're talking about. And, as an FYI or a reminder, the chapter 3 material is technical. and it can be, and it's very precise. The thinking is very is exacting. So it's if you feel like if you're playing a game of Twister or you're thrown off, you want to make your confusion known very quickly, because it's easy to get lost in the stuff. You should remember, if I can do it, anybody can do it. But you do need to keep at it, right? Pretty much on a daily basis. And you need to seek help. You need to talk about it. You need to practice. This course, I've mentioned before, involves skills, which mean you've got to, in order to hone your existing skills, to sharpen your existing skills, you got to practice. And I have the discussion, or sorry, I have the workbooks and answer keys for that. Okay, so the types of interpretations we're talking about, right? So we can say something like this. Suppose that we say, happy cows come from California, right? Does everybody remember the Happy Cows commercial that I showed you and we talked about together? Thank you, Brian. Good. Because otherwise, I want you to refer back to in your memory. I'm not going to replay the video. So happy cows come from California. Okay, so we can so on a oopsie. So let me rephrase that. Categorical logic interprets this sentence, this statement, in terms of what's known as quantity, quality, and term or category relations. So here's what we do. How many happy cows? In other words, actually, let me rephrase this. How many happy cows? At least one? All? Right? And does the statement affirm or deny the relation between the two categories? Right? And then, and by the way, you don't have to work in this order, but these are just this is the order that I wrote the original sentence up here. So what are the two categories? And then propositional, also known as AKA sentential logic, interprets this statement as what's known as simple. And just as a quick FYI, because we're going to study this later, so I don't want to confuse things now, you would just basically pick the capital letter H to stand for the sentence as a whole, stands for the statement. We'll talk more about this, right? So I'm going to put 3 dots here. Okay. By the way, I just realized, I don't know, I need more coffee, that last week, I record every week, and if I'm not mistaken, I uploaded the video from last week's meeting. If I didn't, as the kids say, my bad. I will upload it. But remember, you can always refer back to a class meeting video to either refresh your memory, or obviously if you've missed a class, to watch what we talked about. Okay, I should have looked at that video to remember which whiteboard notes I made. But anyway, our focus right now is on categorical logic. Okay, so before moving on, does what I'm saying A make sense, and B, is what I'm writing legible? Does anybody have questions about what I'm writing? Does anybody have questions about what I'm saying? And by the way, I'm not asking just as an excuse to have a sip of coffee. I'm having a quick sip of coffee while I'm waiting to hear from you. Jake, thank you. Yes and yes. Okay. All right. I'll take Jake's affirmation as standing for the whole class, because I'm going to take silence as approval. But please don't be shy. If you got a question, problem, confusion, I want to know. Okay. New whiteboard. So now let's drill down and into the propositions that we get in categorical logic. First, I want to orient your thinking in a way that for at least some of you might be very helpful. For some of you, it might not be helpful. So figure out who you are, and if it's not helpful, let me know. One way you might approach the technical work that we're doing so that you can avoid feeling overwhelmed by the technical stuff is in terms of a game. If you like playing games, whether we're talking about video games or card games, chess, or a sport, right? You know that there are either pieces or players or positions, right? So you've got your game elements, and then you've got rules of the game, right? So for example, a soccer ball is not the same as a basketball, is not the same as a football. Those are game pieces that are specific to the game in which they are traditionally played, right? A tennis ball is not what we use when we play soccer, right? So one way you might think about the sentences that we're going to look at is in terms of the sort of game piece that we're dealing with. And here's something super cool. The game pieces that we're dealing with are few in number, but we can do lots of interesting stuff with them. Okay, so and by the way, Connor, we are going to get to your super awesome question, I promise. All right. In categorical logic, statements, sorry, I'm trying to go quickly and write legibly, and it's not easy for me to do. Statements I'm sorry, I should start the sentence in this other way. Forgive me. In categorical logic, there are two types of quantity and two types of quality. Okay? So quantity is how much, if you will, and quality is in what way. So how much is going to be, like we said before, universal or particular, and in what way is affirmative. Oh, forgive me, please. affirmative, or negative. Okay, so we've got in total then a combination of 4 statement types. So there is a total of 4 statement types. Oh, sorry, for statement types. Okay, are you ready? We have the universal affirmative, which is, and here's now some technical language that it kind of it goes beyond the words that we already understand, universal and affirmative. We know what that means. How does it play out? Well, the standard form presentation of a universal affirmative claim or a universal affirmative proposition in categorical logic is all subject class are predicate class. We have the universal negative, no subject class are predicate class. We have the particular affirmative, which is some subject class are predicate class. And as usual, I'm running out of whiteboard. I apologize. Just take it from me a standing apology on pretty much everything I do. Particular negative. It's not an excuse. It's just it is truly an apology. I don't mean to be unclear or run out of board space. Negative. Some subject class are not predicate class. Okay, so let's talk about these. Remember, we said that a categorical proposition consists of quantity, quality, and categories. Quantity, universal or particular? What are we talking about? Universal means everything in the class in question, either affirmatively or negatively. Particular means at least one thing in the class in question, affirmatively or negatively. Pause. What do we think? Does this make sense? These are our game pieces, folks. And remember, when you play a game, you don't say, well, why are we using this ball? Or why, by and large, we're excited to play a game. We want to know what the game pieces are and what the rules are, and boom, off we go and we learn to play the game. We're gonna do that here too. We haven't got to the rules yet, right? But what do we think? Does this make some sense? Please don't be shy. I want to hear from you. Yes, no, kind of, sort of. What are we thinking? Okay, good. Now it may be, and I don't know, like Amanda was the first to pipe up. Thank you, and thank you, Brian and Isabella. I don't know if Amanda, if the yes, yeah, or yeah, right? Since we're not together, it's hard to tell. But if you say yeah, sort of tentatively, like, okay, Mia, sure, but I don't know where we're going, that's okay, right? We're right now, it's kind of like I'm presenting the game elements, and then we'll start playing the game. We'll get some rules as we go. Okay. In other words, you actually already know what the rules are. I'm just going to hopefully clarify them and put them in technical terms for you. All right. So quantity, affirmative or particular, right? I said affirmative. I apologize. Quantity, universal or particular. Quality, affirmative, negative. And then lastly, what are the terms or classes that are related? Well, we've got the grammatical subject of the sentence, the grammatical predicate of the sentence. We have the subject class, the predicate class. Okay, so before providing some examples, let me offer you this. We've also got a shorthand for our proposition or claim types. The universal affirmative is typically called the A proposition or the A claim. The universal negative is typically called the E proposition or the E claim. The particular affirmative, and do you see where this is going? A, E, I, O. The I proposition is what we say, or what we call the particular affirmative, and the O proposition is what we call the particular negative. A, E, I, and O, these are just shorthand for the full sentence. We'll see as we go forward that one way to play the game is to think just in terms of the claim type, A, E, I, or O, right? What we'll learn later is involved in the mood of an argument. So A, E, I, and O are just shorthand. If we know we've got an A proposition, we know what that logically looks like. We know what the logical structure is. Okay. All right. So quick history point. The origin of categorical logic is in ancient Greece, specifically with Aristotle. So Aristotle's interested in what we can demonstrate from general propositions, right? So, knowing something about a single item, an individual, is perfectly fine. But let's think about, how the scientific enterprise proceeds today. Think about, for example, the COVID vaccination. We don't want to know if this vaccination works for this one person. We want to know if the vaccination works for everyone, right? So yes, there's this process of testing out on sample sizes, and there's this very, sophisticated technical method for undertaking clinical trials. But think about what we're after in any scientific endeavor. We're after understanding nature as a whole or in part, not this particular individual on their own as a sort of singular entity, right? We want this knowledge that holds for the individuals. So Aristotle says, okay, what are we talking about then? Well, we're talking about either everything within the class in question, or we're talking about at least one thing, right? Where we don't know the scope, right? So the particular claim says at least one. We don't know how many beyond that, right? So the claim is much more specific, okay? But it still is not a singular claim. That is a claim about this individual, all right? Okay, so we've got our A, E, I, and O. So now going back to this claim, remember? Happy cows come from California. Now, do I know if this claim is true? No. But for our purposes, I don't care. I want to interpret the claim using the standard form that is for the categorical proposition. So I ask, okay, in the advertisement, what is the quantity that is implied? It certainly isn't explicitly stated. You know it and I know it. It doesn't say every, it doesn't say all, it doesn't say none, it does, right? It doesn't say some not, right? So how do I interpret it? Well, I think the advertisement is saying, because it is an advertisement, all happy cows or every happy cow, right? So all, I think they're making an affirmative claim. I don't see any negative in there. All happy cows. Now, this is interesting. Not hap cows, happy cows. This is interesting because I don't have my subject and predicate explicitly asserted in the way that we see in standard form. So I'll say something more about that in a minute. But what are the two classes of thing? Well, we've got happy cows, and then we've got, let's say, cows that come from California, or we could say things from California, right? So what if I proceed as follows? I know that the grammatical predicate is the phrase come from California. Well, I need to put that into either a noun or a noun phrasing. Why? Because in categorical logic, standard form, remember what we're talking about. We're talking about categories or classes of thing, right? We want to know about things in the world. So we say, are cows from California? So that's one way I can interpret the parts here. Now let me pause for a minute. Here's our subject class. Here's our predicate class. And then take a look at the conjugation of the verb to be. We always need, and hold on just a sec because the A in the R wasn't clear. This is called the copula. It's what brings together the two classes, right? So we are always going to have a conjugation of the verb to be. Typically it's the plural are, but depending on the grammar, you might have is, right? So what do we have now? Well, we've got the quantity. And by the way, because we're using the word all, we also have the quality. And then, like I said, we've got the subject term or subject class, a copula, and the predicate class. So when we're messing about, right, with ordinary English sentences and we want to realize their structure, their logical form in terms of categorical logic, we're going to rewrite the thing as one of the four claim types. So you've got, sentences out there in the universe, and you say, okay, quantity, quality, or you might say, is this an A claim, an E claim, and then you reorganize accordingly. Now, why do you want to put the sentence in standard form for a categorical a categorical proposition? Well, once we get the thing in game ready shape, right, we get the sentence in standard form, we're going to be able to draw inferences and make sense of things, right, in terms of the logical inferences that are necessary or not. Now, Connor asked this awesome question about this fancy pants phrase, existential import. So let's give this a whirl. Okay. We can further interpret the subject class of a universal proposition in terms of existential import. Now, you can unpack the phrase existential import and get to where you want to go, but here's a way to think about it. A member of the subject class is assumed to exist, right? So when we say all happy cows are cows that come from California, there's the further assumption that at least one happy cow exists, right? So let me give you a breakdown of when we do and when we don't. Existential import is assumed in one system, or sorry, let me rephrase that. One version of the system that is in Aristotelian or traditional logic. Existential import is not assumed in the other version, the modern system. Now, again, there are two ways to think about what we're doing. Well, more than two ways, but I'm going to pitch the second. The first we already know. We're playing a game. We're looking at game pieces. We're starting to look at how we can think of the game pieces or how we're going to use the game pieces. The second is think about what we're doing as a really great intellectual exercise, right? So one way to think about it is this: if you do lunges, right? You don't do lunges so that you can become a great lunger. You don't do jumping jacks so that you can become a great jumping jackser, whatever. Doesn't matter. Point is that you exercise either in a specific way, either because you're a dancer or you're a football player, right? Or you're a tennis player. You exercise in a specific way because you want to develop certain muscles that you don't ordinarily use, or because you're working on some aspect of your health, right? Think about what we're doing right now, if it helps you, as exercising certain features of our existing skill set so that we can be stronger and more flexible thinkers. Okay? So, analyzing the logical structure of our language is incredibly useful to us as readers and thinkers and hearers in general, but also specifically of arguments. So now, just to make more sense of this idea of existential import, what if we do this? So let me take the claim again, all happy cows, and I'm going to abbreviate just for the sake of having less to look at on the page, are cows that come from California. So I'm just going to put RC for come from California. I can do this. I can nest circles as a way to visualize the logical structure of the sentence, right? So here are all the HCs. Where are all the HCs? Every single one of them is dumped into the California class. How many people go, yeah, I see that. That makes sense. What do you think? You okay with that? Now, I don't know about you, but I'm a little unsure. I mean, I guess I can assume that at least one happy cow exists. I hope that's true. I mean, I guess the best, if there aren't any happy cows, the best I can hope for is an emotionally neutral cow, right? But if I want to assume that at least one member of the subject class exists, I'm going to do this. I'm going to say, okay, I'm going to put a little X here. That helps me assume that there is at least one thing. Now, as an FYI, everybody, this assumption has implications, literal implications. In other words, this assumption is going to let me make certain inferences. That's what we're meant to be talking about this week, this idea of a square of opposition set of inferences. So if, we've got our 4 claim types, we've got our 4 proposition types. If I have a universal affirmative, What does that tell me about inferring a universal negative? What does having a universal affirmative tell me about inferring a particular negative? Right? That's the direction we're going. On the other hand, if I don't assume existential import, that's going to limit the inferences I can make. Right? So I'm telling you that's the case. We haven't seen it yet. Okay? Now, one of the ways that we can think about the logical structure of our categorical claims is in terms of these diagrammatic representations. So let me do this. Let me go ahead now and rewrite the standard form. Is it fair to say, everybody, that when I'm talking about, when I express a universal affirmative, I'm saying whether I assume that there is a member of the subject class or not, I'm saying that the scope of this universal affirmative, right, tells me that every single S that is or may be is dumped into the P class, right? All dogs are animals tells me that every single dog, whether we're talking about possible or actual, every single dog falls within the falls within the predicate class. On the other hand, no SRP represents exclusivity, right? When we're saying not even one S is a P, we're saying that the entirety of the S class excludes from itself the entirety of the P class, and so by conversion, the opposite is also the case, right? If not even one member of the S class is in the P class, here's one way to diagram, right? Then that means also that every single P is excluded from the S, right? So the scope of this universal negative covers both terms, both classes in their entirety. Some S are P and some S are not P these are two propositions that are harder to diagram in terms of nested or exclusive circles. So, if let's say we've got an S. Now notice I'm going to put an X in the overlap because I need to say there is at least one S that is a P. And then here, there is at least, I'm putting an X here. There is at least one S that's not a P. Now these two overlapping circles are what we're actually going to use as a template for diagramming every single one of our four claim types. So, and forgive me for rushing through, but I want to at least say it, and then when you go back into the material, or maybe you think a little bit about it, or you start working on exercises, things can start to gel for you. And by the way, not everybody loves this visual expression of the logical structure of a categorical proposition, but you will love it if you don't, eventually. So let's use the same for the universal affirmative and the universal negative. I'll just throw this out there. To say that all SRP is to say that nothing can go in the shaded area, right? So that means that whatever S's there are, they're dumped into the overlap area of S and P. If we say no SRP, we're saying that there can't be even one thing in this area of overlap. So for some of us, shading is a bit confusing, but short story. Shading means there's no there, right? You can't put something into a room that doesn't exist. Okay, now I know we're at time, but what we've got in this set of diagrams is a way to understand what inferences are possible whether or not we assume existential import. Okay, so we'll keep talking about that as we go forward. Hannah asked this great question: what about all squares are rectangles, but not vice versa? Yeah, great question. When we say all S are P, we're not also saying all P are S. On the other hand, when we say no SRP, we're also saying no PRS. That is what we get to next week. Excellent anticipation, Hannah. All right, so as usual, everyone, if you have questions, problems, confusions, let me know. I promise right now I'm posting the whiteboard notes. I'll also check our video from last week to make sure that I posted it, and I'll check for those whiteboard notes. If you have questions, problems, confusions, don't wait. I'm here to help, not just during regular office hours, but outside if you want to chat. Okay? Have a good one, everybody, and I see you next week, if not before, okay? Thank you.
Thank you.